I'm going to do a few problems on the 6162 review just to give you an idea of how the questions can be solved. So one set of problems, the first set of problems for the quiz are asking you to simplify each radical. Remember that if we're going to simplify a radical, we have to think in terms of perfect squares. So our perfect squares are 4, because that's how you get 2 squared, 9. If you do 3 squared, you get 9. 4 squared, you get 16. So if we keep going up, we get 25, 36, 49, 64, 81, 100, 121, and 144. Now, obviously, we could keep going, but I've asked that you just have them not memorized, but you just realize that those are the numbers that are from 1 through 12 that have been squared. And I said you don't really have to memorize them because they would be on a formula sheet that I'm going to give you for the quiz. Again, so what we want to do for simplifying a radical is rewrite the number under the radical as the product of one of the perfect squares on that purple list and then another number that would not be on that list. And you always, when you look at that list, want to find the biggest number that you can use to create the number under the radical. So again, I'm not going to do all of these, but let me just, let's look at number 3, I guess. All right, so square root of 75. Again, I want to rewrite it as the product of two radicals that actually still multiply to 75. The first radical has to contain a number on the purple list. And so if we look up at that purple list and think what number can go into 75, the only one you're going to find that can do that is 25. And so 25 goes into 75 evenly. It goes in there 3 times. If you don't know that, if you're thinking, well, I wouldn't know that, then you would take all the numbers that are less than 75, which that means we'd start here where I just drew that dark line, and we'd go with all those numbers and say, well, let me get my calculator out and try to divide 75 by those numbers. So if you divide 75 by 64, you're going to get a decimal. If you divide 75 by 49, you're going to get a decimal. The first number that's not going to give you a decimal is that 25. And so that's how you should rewrite 75. And the reason we did that, again, is because the first radical that we wrote, the square root of 25, is what's called a perfect square. And that means you could unsquare it. A perfect square is an integer that's been squared. So the integer that's been squared to create 25 is just 5. So if we simplify the square root of 75, it becomes 5 radical 3. All right, so that's how you simplify radicals. Let's move on to special right triangles. Again, on your formula sheet, I will tell you the relationships that you need to know. You won't have to memorize them. And it'll look like this on the formula sheet. I'll tell you that a 45, 45, 90 degree triangle has 2 legs. We're going to call each of the legs L. And then the hypotenuse is equal to the leg times root 2. And so if we look at the first 3 problems, and again, I'm only going to do 1 or 2 of them, we see that we have a single 45. So let's look at number 5. We have a single 45 and we have a 90, right? And so triangles always make 180 degrees. So even though I don't see it, that must mean there's another 45 there. And so I have to figure out what are the legs versus what's the hypotenuse. The hypotenuse, that definition will never ever change. The hypotenuse is always directly across from the right angle. And so the hypotenuse is the side that's labeled with an A. The hypotenuse is what they is one of the things they want, right? And it says over here again, it says take the leg times root 2. And so the leg is 4. Since the leg, any side that's not the hypotenuse must be a leg, all right? So since the leg is equal to 4, that means the hypotenuse must be 4 times root 2. And the other leg, which they're calling B, because remember that these kind of triangles have 2 legs that are identical, will also be 4, because B is also considered a leg just like the 4 on the other side. On number 6, you'll see that they gave you the side that is directly across from the hypotenuse. I'm sorry, across from the right angle. So they gave you the hypotenuse, right? The hypotenuse is 8 square roots of 2. Well, since this is our hypotenuse, we know that it was equal to the leg times root 2. And so since there's already a root 2 on our hypotenuse, the number in front must have been our leg. And so our missing x and y are our legs. They're both going to be 8. So that's 45, 45, 90s, and that's basically what you need to know for the quiz. If we move on to 30, 60, 90s, those start at number 8. And the relationship that you'll be given on the formula sheet will be that 30, 60, 90s have a short leg called S. That will be the side that's directly across from the 30-degree angle. So if we look at the picture that's in problem number 8, if you go across from the 30-degree angle, you see that there's a 3. That means the short leg was 3. The long leg, if we want to know the long leg, that will be the one across from the 60-degree angle. That will be the short leg times root 3. And the hypotenuse will be double the short leg. So like I said in problem number 8, we know the short leg. It's always across from the 30-degree angle, so we know that S is equal to 3. Across from the 90-degree angle, like I said a minute ago, will never change. That's always the hypotenuse. So if you double a 3, you get 6. And then across from the 60-degree angle, which they didn't show, but again, I know triangles make 180, so I know it's there. That across from the 60-degree angle is side V. And again, that's my long leg. My long leg's always across from my 60. So that will be my short leg, which is 3 times root 3. All right, so that's how you do 30, 60, 90s. Let me do one more. If we look at problem number 10, we can see that they gave us the hypotenuse because they gave us the side that's directly across from the right angle. So I know that my hypotenuse is equal to 4. Well, again, if you look at the relationship up above that I've written in purple, it says that was double, right? That was double the short leg. Hypotenuse is always double the short leg in a 30, 60, 90. So that means the short leg must have been 2. Because what do you double to get a 4? You double a 2. So again, I don't see all the angle measurements I'm supposed to see, so I can pencil them in if I need to. The 30-degree angle has the short side right across from it, so Y is going to be my short side. And again, if my hypotenuse was 4, my short side must have been 2. My long leg will be across from my 60, and it is the short leg, which was 2 times radical 3. And I'm getting that all from these relationships I've just highlighted in yellow, and these will be on your formula sheet. All right, the last thing on the quiz is the Pythagorean theorem. The reason you know you're supposed to be using the Pythagorean theorem on these problems is because 2 sides are labeled. Anytime you have 2 sides of a right triangle that have been labeled with numbers, you can use the Pythagorean theorem. And so the Pythagorean theorem says the hypotenuse squared is equal to one of the legs squared plus the other leg squared. So if we look at something like example 11, it's saying the hypotenuse squared, which is my x, right? If you go across from the 90, that's your x. X squared is equal to, take your 2 legs, which are 2 and 3, and square them and add them together. So always add your legs together and leave your hypotenuse alone. So we have x squared equals 4 plus 9. X squared equals 13 when we combine our like terms. If we take the square root of both sides, which we must do because we need to unsquare our x, we get x equals, well, the square root of 13 is perfectly acceptable. Look at the directions. It says you can leave it in simplest radical form, or if you want to take your calculator out and go to the nearest tenth, that's fine too. So you can either leave it as the square root of 13 because there's nothing I can do with that, or you can take your calculator out. Let me see if I can find my calculator, and we can actually take the square root of 13. So if we do that, we're going to take the square root of 13, and we're going to get 3.6. So we could have also stated it as 3.6. And if we were being really good, we would put the kilometers on there, the units, but I won't take off if you don't do that. So either 3.6 or the square root of 13 are perfectly acceptable answers. So if I do one more, let me just do something like, actually, let's do number 14. 14, this time the hypotenuse, which is the 4, it's a number, right? It's not the variable. So always think about, is the variable going to be your hypotenuse and should be all alone? Or is your variable on one of your legs and should have something added to it? So in this case, my variable is one of my legs. And so I'm going to take the x squared, but I'm also going to add the other leg to it and square it, because that's what the Pythagorean theorem says. Take the legs and square them and then add them together. And that would be equal to the hypotenuse squared. All right, so the reason I wanted to do this one, the reason it's different than number 11 is because in number 11, notice how the x was all alone because it was the hypotenuse. And in number 14, the x was being added to the square root of 5 squared because it was a leg. It was not all alone. So the important thing to remember is to keep your hypotenuse alone when you set up the equation and to make sure you square everything. And then the second reason I picked this one is because I've talked a lot about the algebra in this class, how to manage your radicals. And so whenever we take a square root and square it, like we've done with that square root of 5, so let's write our x squared again, these two things actually cancel each other out. The squaring and the square rooting cancel each other out. And all you're left with then is the 5. So anytime we square a square root, we cancel everything out and just get the number underneath. All right, 4 squared is 16. If we subtract 5 from both sides, we end up with x squared equals 11. And again, to unsquare your x, you have to square root it. To unsquare your x squared, you have to square root it. And what you do to one side of an equation, you must do to the other. So you have to square root the 11. And again, you could turn this into a decimal if you want, but you know how to do that, I would hope. All right, the only other thing that is on the quiz are some word problems. There'll be 2 word problems. And so you have to be able to sketch the picture, and then you have to label all the sides in your picture with either the numbers or a variable. And then in part B, you'll have to figure out how to use the Pythagorean theorem to solve it. So I'm just going to do one of these. It says a pigeon leaves its nest and flies east. If we look at the compass rose over here on the side, you can see east is pointing over there to the right. And so this pigeon is going to head right when he first starts. So think about that. His nest is somewhere, right? We'll give it his nest. We'll give it a little dot. And he's heading east. He's heading this way. And they said he flew for 5 miles when he headed east. And then he changed directions and started heading north. And so north again from our highlighted compass is heading up. And so that would be 8 miles heading up. And then we always want to build a right triangle. So far we do have 2 lines meeting at a right angle, but we want to finish off that triangle. And that will be your unknown. That's going to be your x because you don't have a number to put there. And that is representing how far the pigeon is from the nest. And so part B, all you actually have to do is solve that. And so if I start with my x, that's how I like to start my equations, is with my variable. I know it's the hypotenuse, right? Again, it's across from that right angle. It will be all alone, so I'll write my equal sign, and then I'll take my 2 legs and add them up. And we end up getting x squared equals 25 plus 64. We get x squared equals 89. On word problems, I really don't care. Again, if you want to give me the simplified radical or do you want to round to the nearest tenth, but what I do care about is if you include units. You'll get a half a point for your units. And so let's actually finish it by taking the square root. So again, if you want to leave it as square root of 89, that's fine. Or if you want to get your calculator out and actually take square root of 89, you'll get 9.4. And so you could turn that into 9.4 or leave it as the square root of 89. Again, I don't care. You could see what I highlighted in yellow in the directions. It says either way. But what I do care about is units. So put the miles on there. All right, so all word problems work like that. You will draw some sort of right triangle. You will label 2 of the sides and put a variable on the third, and then you will use the Pythagorean theorem to solve it. So there's some hints on the review. I hope that helps.